Okay. Good morning to everyone. Can you hear? Is voice is audible? Okay. Thank you. Please check the screen is visible to you. Okay. So okay. Actually, I prepared a PPT already. So mostly I will use PPT whenever you have a doubt. So I will explain. I will write and then explain. Uh, First two unities, most of the part contains mathematical logic. So actually, in this slide, I'm going to tell what is a proposition and what is a statement. So both of them are same, proposition or statement. So I gave some of the examples here. So yeah, declarative sentence or a declarative assertion, which is either true or false, but not both. For not both means sometimes it is true, sometimes false. So it is, so that's why I put here what, but not both. So either it should be true or false. Is called a proposition or statement. Sentence which are exclamatory. So you know what you mean by exclamatory. Interrogative means it ends with what, a question mark, or imperative in nature are not propositions. Lowercase letters such as PQR. Usually we will use a lowercase. Sometimes they will use capital letters also to use it to denote proposition. For example, we consider the following sentence: New Delhi is a capital city of India. So actually, this is true. So that's why it is called a proposition. How beautiful is Rose? So it is interrogative. So that's why it is not a proposition. So 2 plus 2 equal to 3. It is false. So that's why it is a proposition. What time is it? So again, it is interrogative. It is not a proposition. X plus y equal to z. It is sometimes true, sometimes false. So depending upon the values of x, y, z. Suppose x is 1, y is 2, z is 3 means okay, it is true. So x is 2, y is 3, and z is 10 means it is false. So it is not proposition, because sometimes it is true, sometimes it is false. Take a cup of coffee is a imperative sentence. So that's why it is also not a proposition. So here they gave the reason in the statement 2, 4, 2, 4, 6 are obviously not proposition, or they are not declarative nature. I told that 2 and 4 are interrogative and 6 is imperative. 1 and 3 are proposition, because this is true, this is false. Okay, and 5 is not, because 5 is neither true nor false. Okay, as the values of x, y, z are not assigned. Okay. So next, in this slide, first I gave the definition of what is the TF statement, that is true false statement or a proposition. Is a true false statement is a declarative sentence to which it is meaningful to assign truth value, either true or false, but not both simultaneously. So connectives, uh, okay, there are, I think, for 5 connectives are there. The first one is conjunction. So here, I think it is visible to you. Otherwise, I will write here. Okay. So Balachi, bold எழுதி. Okay, I'll try. P, Q, Okay, P and Q, that is conjunction. Okay, so usually for two variables you have two square. Okay, true, true, false, false. For Q, true, false, true, false. So it has only false. It has false if we have a P is sorry. Okay, this is and. Okay, and means both of them should be what, true. Okay, what, both of them is true. Then only it is what, true. For all other cases, it is false. For all other cases, it is false. So here it is given when P and Q are two proposition P and Q denoted by P and Q or P cap Q is called a conjunction of P and Q, is defined as a compound proposition. It is true when both P and Q are what, true, and is false otherwise. For remaining cases it is false. So here this cap is the connective used. So this is the truth table. Here you can see. Okay, so next I'll go to disjunction. Okay, so in disjunction, if both of them are false, it is false. The remaining all other cases, it is what, true. So you can see here when P and Q are any two propositions, the proposition P or Q, which is denoted by P or P cup, that one is cap, this one is cup. Okay, P or Q denoted by, or you can read P or Q also, and it is called disjunction of P and Q. It is defined as the compound proposition that is false when both P and Q are false, and it is true otherwise. Okay, this is the truth table for disjunction. Okay, next negation. This is also a connective. So I think you can easily write the truth table for negation. So P negation P, it is true na false, false na true. Okay, next one is conditional and biconditional. So here in the conditional, I will write here P, Q, P implies Q. So this is if P then Q. So true, true, false, false. This is what? True, false, true, false. It has false. It is false only if P is true, Q is false. Remaining all other cases, it is true. Okay, I'll read. Okay, so I will read the definition here. If P and Q are propositions, the compound proposition, if P then Q. So we read like this: P implies Q is if P then Q. That is denoted by, this is denoted by P implies Q is called conditional proposition, which is false when P is true and Q is false. So and true otherwise. So that means the remaining all other cases it is true. You can see here. Okay. So if this conditional proposition P, actually this P is called hypothesis or premise, and Q, this Q is called conclusion or consequence. Okay, so next connective biconditional. Okay, first I'll explain the truth table and then I'll go to the definition. So here again I'll write here PQ P biconditional Q. So here it is again true, true, false, false. True, false, true, false. Okay. So P biconditional Q. Okay. So actually you should read P if and only if Q. So here it is mentioned. Okay. P if and only if Q. So it is denoted by P biconditional Q is called biconditional proposition, which is true when both P and Q have same truth values. So where it is have a same truth value, here T, so then T. Here both of them are different, here both of them are different, here both of them are same. So here also T. So false for the remaining cases. Otherwise it is what? False. That's all. So here you can understand this P biconditional Q slightly other ways also. I will tell how. I think you know that. Okay, I'll explain you quickly. P Q should write. First P implies Q should write, and then Q implies P. Okay. Okay, I don't have enough space. So maybe I'll write in the next slide. I'll write one more slide. Slide. Next Puna. Okay. 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 Plus spot. Okay. Okay. So now I'll tell you PQ, P, Q, P implies Q, and then Q implies P, and then P biconditional Q is same as P implies Q, P implies Q, and that is this is what Q implies P. Q implies P, close bracket, or which is same as P biconditional Q. So here this is true, true, false, false, true, false, true, false. P implies Q means it is false only if it is true, it is false. Remaining other cases, it is what? True. Q implies P means whenever it is this is true, this is false, this is false. Remaining all other cases, it is what? True. Now, and so and na okay, okay, I'll write put a line like this. Okay. So here in this case, you have what? T na. Here also you have what? T. Here F T na. F. This is here. It is F. This is T. So you can see here T F F T. In the previous slide also you can see T F F T. So from this we know that additionally P biconditional Q is same as what? P implies Q and Q implies P. Okay. Now next concept, atomic and compound statements. So this is a definition purpose you should know. Okay. So a statement which do not contain any connectives are called atomic or primary or simple statements. On the other hand, the statements which contain one or more primary statements and at least one connectives are called compound statements or composite or molecular. Okay, so example for atomic statements. So today is Sunday, so there is no connective. Okay, it is raining. Okay, so these are all examples for atomic statements because it does not contain any connectives. If you go to the next slide for compound statements, so here it is not true that 3 plus 4 equal to 17. Here not is negation, is a connective. It is not true again. Here not is what? Negation, connective. If this sweet is prepared by pure ghee, then it is good for health. If then is a connective. So Jack and Jill went up the hill and is connective. He is hurt or he is pretending or is connective. So that's why these are called compound statements. Okay, so we'll go to the problems. Construct the truth table for negation of negation P and negation Q. So sometimes they will use negation also like this. Okay. So or they'll use like this. Okay. So here we have the variables P and Q. So we have to consider 2 square. That is 4 possible combination for truth values of the two statements P and Q. So first to P, you should write T T F F. And for Q, T F T F. So negation P means if it is T na false. Okay, first of all, you should decide what are the variables you need, because if I gave the table, you know that. Okay, first if you see this question, so you should write like this. So I need P. Okay, even though it is negation P, negation Q, I need what? P. I need Q. And then I need what? Negation P. And then I need what? Negation Q. And then I need what? Negation P and negation Q. And finally, I need what? Negation of this. So that is what? The last one. I don't have enough space. So first of all, you should decide. So how many columns you need? If you write correctly, there is no need to rewrite. Suppose if you missed anyone, then you need to add somewhere else. Okay. So that's why before starting the table, you should decide how many columns are we need to write. Okay. Okay, I told that what is P and Q. Similarly, negation of PK, T na false, T here false, false not true, false not true. Similarly, for Q, negation Q, you need to write. Okay, we have 4 columns, first 4 columns. So next, negation P and negation Q. Here have and. So false, false na false, false true na again false, true false na and na false na, true true na true. So now I need negation of this column, this quantity. So true, 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 false. Okay. So I think if you have any doubts, you can ask to me. Otherwise, I'll go to the next problem. Determine the truth table of the formula P implies Q implies R. So here I have three variables. So 2 power 3 equal to 8 different sets of truth values. So we need to assign for the variables P, Q, R. So this is, if you take, this is P, this is Q, this is R. First four are what? True. And the next four are what? False. So if you take in this order, then it is very easy. So next for the second variable, T, T, F, F, and then T, T, F, F. And the last one, alternately you have what? T, F, T, F, T, F. Okay. So first three columns, I told that already. Now Q implies R. So this is if P, then Q. Okay, conditional. It has it is false only if Q is true, R is false. So look at here. Okay, so T is true, Q is what? False. Similarly, here T is true. Oh, sorry, Q is true, R is false. So remaining all other cases, it is true. And then P implies, okay, well, P implies Q implies R. These two columns I need to consider. So it is false only if what? It is true and this is false. That's why you have false. And similarly, check it where it is false here. But here I have F only. So remaining all other cases, it is what? True, 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 true. That's all. Over. So this is also comes under a truth table. The first class, this class I can concentrate the problems related to truth table. From the next class onwards, using uh, identities, we will solve the problem. Construct the truth table for the formula negation P or Q and negation Q or P. Here have P and Q only. So again, first you should decide what is the variables you need. What is the column? P we need. Okay, wow. Q, PQ, and then negation P. Okay, well, negation P is here, and then negation Q is here. Okay, and then negation P or Q, and then negation Q or P, and then I need a disjunction, okay, well, of and negation P or Q and negation Q or P. So I think this is slightly easier. I think you know P and Q how to write. So negation P means whenever it is true, this is false. Whenever it is false, this is true. Similarly, you should fill up what? Negation Q also. And then negation P or Q. Okay, well, that means these two. Negation P or Q. So true, false, na true. False, false means false. True, true, na true. So at least one of them is true, not true. Both of if it is false, only if what? Both of them are what? False. Remaining all other cases, it is what? True. Similarly, next negation Q or P. Negation Q or P. So so true T F na T da T T na T F F na F F T na T. Okay. So next these two I'll put and. So it is true, both of them are true. Otherwise, it is false. So T T na T, T F T na F, T F now F, T T now T. So similarly, again this column contains more columns. You can see here. Construct the truth table for the formula P and Q or negation P and Q or P and negation Q or negation P and negation Q. First of all, basic we need P and Q. Okay. And then look at here. I need negation P. I need negation Q. Okay, negation P, negation Q. And then the first one, P and Q. Second one is what? Negation P and Q. Third one is P and negation Q. Fourth one is negation P and negation Q. And finally, uh, we'll put what? R. In between these four expression, I'll put what? R, R, R. Okay. So I think I can easily understand this problem. Okay, that's why I'll skip this problem. And then if you have any doubts, you can post here or you can ask me later. Okay, the next concept is tautology and contradiction. So actually, tautology means the truth value is what? True. So then we say that it is tautology. If the truth, this value is false, okay, then we say that what? It is contradiction. So the definition here, just I'll read. A compound proposition P is P of P1, P2, Pn, where P1, P2, Pn are variables, is called a tautology if it is true for every truth assignment for P1, P2, Pn. And P is called contradiction if it is false for every truth assignments for P1, P2, Pn. For example, P or negation P is what? P or negation P is a tautology, and whereas P and negation P is what? Contradiction, as you can see from this table. Okay, so some of the observation here. The negation of tautology is contradiction. The negation of contradiction is tautology. So this is is, but second one, if P of P1, P2, Pn is a tautology, then P of Q1, Q2, Qn is also tautology, where Q1, Q2, Qn are any set of propositions. So this is known as principle of substitution. Okay. For example, we have P or negation P. If it is tautology, then instead of P, I am going to replace by P or Q and R. Okay. Instead of P, I replace by everything. And then I'll put this R. Okay, this R is here. And then this negation is here. Again, I should write this P. P is what? P or Q and R. So, if this is tautology, this is also tautology. So that is given here. Principle of substitution. Okay. Okay. Now, if this is tautology means this is also tautology. Okay. So if your proposition is neither tautology nor a contradiction, it is called a contingency. So now we will solve one or two problems in tautology. So verify whether P or Q implies P is tautology. So we need what? P and then Q and then P or Q and then P or Q implies P. So first you should decide what you need. Okay, so P and Q you can easily write. P or Q, it is false only if both of them are false. Remaining all of the cases, it is what? True. This is a conditional statement. P or Q implies P. So that means from here to, you are going from here to here. So it is false only if this is true, this is false. Okay. Okay. If this is true, this is false. For remaining all other cases, it is what? True. Okay. This is not a tautology. This is not a contradiction. So and hence it is a contingency. It is not a tautology. Okay. Now, okay. Now write down the truth table for the following compound statements and state which of them are tautology. So the first one, you have three variables, P, Q, R. So a little bit lengthy. The second one is you have P and Q, only for two variables. Third one is also you have what? Two variables, P and Q. Okay. So, okay, first we will discuss the first one. So, for the first one, what you need? P, Q, R, and then negation R also you need, and then QRR, and then P and negation R, and then QRR implies P and negation R. So that is you can see in the next slide. So P, I think I told that for PQR, first to P, first four of them are true, next four of them are what? False. For Q, TTFF, TTFF. For R, alternative are TF, 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 TF. Okay, QRR. So QRR na. So it is false only if both of them are what? False. Okay, remaining all other cases, okay, remaining all other cases, it is what? True. You can see here. Similarly, negation R, you know that if it is R is true, negation R is false. It is false now, it is true. Similarly, you need to fill up this column. And then P and then negation R. P and negation R now, these two columns. So and na, it is true. Uh, both of them are true. Remaining all other cases, it is what? False. So you can check here this column and this column. Okay, T F F T T T. Similarly, you need to fill up this column. So again, I'll repeat. If for and both of them are true, not true. For remaining all other cases, it is what? False. Okay. Next, QRR implies, okay, you are going from here to here. So P implies Q. Consider this is P, this is Q. So P implies Q is false only if P is true, Q is false. So check it. T F na F, T T na T, T F na F, F T na T, T F na F, T F F, T F F, F F na T. Okay, so if you have any doubt in this up to this, okay, you can ask to me. But from this, you can easily tell this is not a tautology, okay, because it is mixture of T and F. Okay, so next problem is P and P biconditional Q implies Q. So from this from problem, first you should write what you need. P I need, Q I need, and then P biconditional Q I need, and then P and P biconditional Q I need, and then finally you should write this whole everything. Okay, so now first you should write the first two columns. P biconditional Q, already I told that P biconditional Q, both of them are same truth value. So then it is true. So here TT, that's why T, same truth value. Here also same truth value, FF, T. So remaining all other cases, it is false. Suppose TF, FT is false. Next, P and so P biconditional Q. It is true only if both of them are what? True. Remaining all other cases, it is false. So TT na T, TF, F, FF, F, FT na F. Next, P and P biconditional Q implies Q. So I am going from here to here. Okay, so consider this is P, this is Q. Okay, P implies Q is false only if it is true, it is false. So T T da T da, FF nalo T da, FT nalo T da, FF nalo T da. So all of them are true. So and hence it is a tautology. So this is third subdivision. So P implies Q. This is implies Q, and biconditional. This is actually biconditional negation P or Q. So from this I need PQ, and then P implies Q I need. Uh, you can write negation P also here. Okay, no problem. First negation P and then P implies Q you can write. And then negation P or Q I need, and then you should write the whole problem here. So first two columns are familiar to you. So P implies Q, it is false only if P is true, Q is false. Remaining all other cases it is true. Negation P, you know that, and then negation P or Q. So it is or nor. It is false only if both of them are what? False. Remaining all other cases, sorry, P negation P or Q. So it is false. Both of them are false. Remaining all other cases, it is true. So TF na T da, FF na F, TT T, FT na T da. Next to biconditional, P implies Q and biconditional negation. So both way I'll put like this. So I'll take these two columns. Here you know that P biconditional Q, it is true, both of them have same truth value. So check it. T na T, FF nalo T da, T nalo T, T. So and hence this is a tautology. So I leave this problem to you. Okay. So show that Q or P and Q or negation P and Q is a tautology. So you have, it is only two variables. So you can first you should write P Q and then negation P I need, negation Q also I need, and then P and negation Q, negation P and negation Q, and then this portion, or you can write first this portion and then finally you can write. It is up to you because there is no bracket, so that's why they are doing like this. Negation, first they will take R between these two, and then they will take R between Q and this quantity. Okay, so I feel that this problem is slightly easier, but number of column is only what? Little bit more. You can do and understand this problem. Okay, so next concept and the last concept for today class is tautological implications and equivalence of formula. Okay, so it is also depending upon the previous concept tautology. A formula phi is said to be tautologically imply a formula psi. A formula phi is said to tautologically imply a formula psi if and only if phi implies, this is actually implies psi is a tautology. So in this case we write phi, this is called tautologically imply. Okay, phi tautologically implies psi. So if there is a phi implies psi is tautology, then you can write phi tautologically implies psi. Okay. For example, in the first example, P implies Q. This is tautologically implied. Negation Q implies negation P. Okay. So to prove this, I need to prove P implies Q implies, okay, single line, single arrow. Okay, negation Q implies negation P is a tautology. If I prove this is a tautology, then this is tautologically implied this. Okay, you can put this symbol. Okay, just now we discussed tautology. So we need what? PQ, and then negation P I need, negation Q, and then P implies Q I need. negation Q implies negation P, and then the whole expression. So first two columns are easy, and third and fourth also you can easily write negation P, negation Q. P implies Q is false. If P is true, Q is false. Remaining all other cases, it is true. Similarly, negation Q implies negation P. So if this is true, this is false. In this case, only what? It is what? False. Remaining all other cases, you can see here. Okay, here T in F. Okay, so in this case only it is true. Remaining all other cases, it is true. Next, last one. P implies Q. That means from here to here. So it is true. If it is true, if it is false, then it is false. Remaining all other cases, it is true. So there is, you can say T T na T na, FF na T na, T T T, T T na T. So and hence this is a tautology. Okay. So and hence this tautologically imply this expression. The next slide. This is a typing. Okay, so P implies Q. Actually, okay. So this is a what I told. This is a tautology. So actually, I need to write here. This is actually wrong. This should be implies. So P implies Q implies negation Q implies negation P is a tautology. The reason is all the entries in the last columns are what? True. Hence, P implies Q. Tautology, here only they'll put what? This symbol. Tautologically imply this symbol. Okay. Okay. So negation Q implies negation. Okay. So I'll move to the next problem. Here, the same idea only. P implies Q implies R. Tautologically imply P implies Q implies P implies R. So if I prove this is tautologically implied, this means this implies this is a tautology. I need to prove. Okay. So here again you have three variables PQR. So first you should write PQR. So you know how to write. P implies Q. Check paniko. Please check it. P implies Q. It is false only if this is true. This is false. So check third row. TF na F. TF na F. So remaining all other cases, it is true. Similarly, you need to fill up what? Q implies R. Q implies R la TF. Okay, sorry. Q implies R na here. Okay, T na T. TF na F. So TF where எங்க இருக்கு? TF is here. So F. So remaining all other cases, it is true. Next, P implies R. Okay, P implies R. So again, the same idea. TF na F. Check பண்ணிட்டே வா. P, okay வா. TF na F. That's all. Remaining all other cases, it is what? True. Next, P implies Q implies R. P implies, that means these two columns. P implies Q implies R. So it is true. If it is false, it is false. Okay, va. So check paniko TF second row. Okay, va. Second TF F. So remaining all other cases, it is true. And then P implies Q. Not this one. P implies Q implies P implies R. So you can check it here. It is true. It is false. It is false. So remaining all other cases, it is true. And I need to write what? One more column. What is the column I need to write? Here they done it slightly different way. I will tell how they done it. I'll take this is A, this is what? B. So better you need to write the whole expression. I don't have enough space, that's why I'll take this is A, this is B. So A implies what? B. Okay. So that is the final expression. So it is true, false. No, it is false. Check panniyo. T, T, F, F, everything is T. So now it is true. Everywhere you should put what? True. 4, 5, 6, 7, 8. So and hence you can easily tell it is a tautology. So now, but in the book they explain like this. So actually this expression and this expression are identical. So that means uh, these two expressions are identical. You can check here. T, T, F, F. Remaining all other cases, it is what? T. So these two columns are identical. So and hence they are telling that the first expression P implies Q implies R implies the second expression P implies Q implies P implies R is a tautology. Okay, you can write like this, or you can put one more column and then you can do like this. That is up to you. So finally, you can write this expression tautologically imply this expression. So tautologically imply a concept is over. Next, the last concept is equivalent. This is also depending upon tautology. So okay. So please mute your. Okay. Two formula phi and psi are said to be equivalent to each other if and only if uh, phi tautologically implies psi and psi tautologically implies phi. So this is one of the way you can uh, you can write the definition of phi and psi are equivalent. So that means equivalent na they'll put like this. This is equivalent. Okay. Or sometimes they will use like this also. Okay, equivalent. Both of them are the expressions for equivalent. Okay. So actually, for this to prove the two formulas are equivalent, you need to prove phi tautologically implies psi and psi tautologically implies phi. In other words, phi and psi are equivalent to each other if and only if phi biconditional psi is tautology. So this is enough. If I prove this is a tautology, then phi and psi are equivalent. Okay. So if phi biconditional psi is a tautology, we can write phi and psi are equivalent. Okay. So note phi and psi are equivalent if only if the truth tables of phi and psi are the same value. Actually, you can see in the previous example 2, I think these two columns are what? Same truth value. So even actually you can put both of them are equivalent. But in the question they are asking only what? This is tautologically implies this. But it is actually what? Both of them are what? Equivalent. Because these two columns are same truth value. So that is they are telling here. By example 2, it follows that the first expression P implies Q implies R equivalent to P implies Q implies P implies R, because both of them have same truth value. Okay, so the first problem in this case, P or Q equivalent to negation of negation P and negation Q. So to prove these two are equivalent, I need to prove the first expression P or Q biconditional negation of negation P and negation Q is tautology. So okay, you need what? PQ, P or Q, okay, and then negation P, negation Q, okay, negation P and the negation Q, and negation of this quantity, okay, and then finally you should write the whole expression. So if you write everything, then you can easily write. First P and Q, you know how to write. P or Q is what? It is false only if both of them are false. Remaining all other cases, it is what? True. So negation P, you know that. Negation Q, you know that. And then negation P and negation Q. And now it is true. Both of them are what? True. Remaining all other cases, it is what? False. And then negation of this quantity. So true na false, false true, false true, true na false. To the next P or Q, you are going from here to here. P, okay. So if it is true, if it is false, then only it is false. Remaining all the cases, it is true. So T T na T, T T na T, T T na T, F F na T. You can see here both truth values are same. T T T F, T T T F. So from this also you can easily observe that both of them are what? Equivalent. So we proved that P or Q biconditional negation of negation P and negation Q is a tautology. So and hence we can say that P or Q is equivalent to negation of negation P and negation Q. So again, this is tautologically implied. Okay, so that's why I leave it to you, but I'll just tell the outline. So Q tautologically imply P implies Q. So for this, what I need to prove, Q implies P implies Q is tautology. So I have two variables, PQ, and then P implies Q, and then Q implies P implies Q. Okay. So P implies Q is false only if P is true, Q is false. Remaining all other case, it is true. Next, Q implies P implies Q. So if it is true, if it is false, now it is. You can see here T T F F T T F T. Okay. Here you can see here. Uh, there is no T and F here, but FT is here, but it will not affect here the truth T value. So everything is what? T. But both of them are different truth values, because here TT, FF, TT, but here FT. So you can't, these two are not what? Equivalent. But the one way is true, the other way is not true. Okay, that means what? Q tautologically imply what? P implies Q. P implies Q does not tautologically imply Q. So that's why, because from this you can easily observe that here F and T. Okay. So again, this is also comes under tautologically imply. For this, you need to prove what? P and Q implies P implies Q is what? Tautology. Okay, I proved it is a tautology. So and hence this expression tautologically implies this expression. So negation of P is again P. Okay. So these two are equivalent. So for to prove two expressions are equivalent, so for this I need to prove what? Both of them, first expression biconditional, second expression is a tautology. I need to show that. So here it is shown that both of them are what? Tautology. So for this I need what? P, negation P, negation of negation P. And then the last, this expression, negation of negation P, biconditional P. So TF Here I have only one variable P. T na F, F na T. Again negation T F. I put biconditional for these two. You can see here T T F F. Both of them are same truth value, and that's why here also T T. So this is tautology, and hence both of them are what? Equivalent. Okay, so now before coming to the next class, you need to uh, know these laws. Okay, so that's why I'll show the next 5 minutes. You need to remember there is remember in the sense you need to solve more problems using these identities, then only you can easily remember. So just to remembering is a little bit difficult, I know that. So okay, so replacement process, that is the next heading. So replacement process la first logical identities. Idempotent law. Idempotent law is P or P is this is actually equivalent equivalent to P. Similarly, P and P is equivalent to P. Commutative law. P or Q is equivalent to Q or P. Similarly, P and Q is equivalent to Q and P. Associative law. P or Q or R is equivalent to combining these two, P or Q or R. Similarly, instead of R, replace by what? And here. P and I think this is not a associative law. I think they done it. I think this is not correct. Okay, this is because they put here also and here also and, but here I think it is not associated. Here it is wrong. It should be P and Q. That is correct. And then again and it will come R. This is correct. So replace okay R by and here R by and. Similarly here what? R by and here what? R by and. Next distributive law. So P R here R here and. So you should write this is equivalent to P R Q and P R R. So replace R by and by R. So you can check here R by and by R. Here R by and by R by and. So you should remember this distributive law. Absorption law. P R here R and under. If you have P and P, then this is equivalent to P. Similarly, here instead of R, here interchange R and. So here and here R, here what? P. So then that is equivalent to what? P. So using truth table, you can verify it. Okay, these replacement process, logical identities. Next, De Morgan's law. You know that complement or negation of P or Q is negation P and negation Q. Negation of P and Q is negation P or negation Q. So first try to remember these 6 and then double negation. You know that P is equivalent to what? Negation of negation P. And then this is I called double negation, or in the book they use I7. In I8, P or negation P is true. T. Okay, and that is we saw that in the tautology. P and negation P is what? False. Similarly, we will use I8 regularly, I9 regularly. I9 is P or T is T, P and T is P. Next, P or F is P, P and F is F. Next, I10. Okay. I10 is actually, I think we don't use regularly I10. P biconditional Q, sorry, not biconditional. P tautologically imply Q and P tautologically imply negation Q is equivalent to negation P. So I think we don't use this one regularly. Okay, but they gave us a formula, so you should remember. Okay, contrapositive. So we will use this one regularly. P uh, actually here they gave tautologically imply. Usually we will write like this: P implies Q. P implies Q is equivalent to you can put this symbol or you can put this symbol, uh, negation Q implies negation P. So usually you use like this, but here they are writing tautologically imply. Here also they'll put tautologically imply. Here also they'll put what? Tautologically imply. But most of the time I will use like this only. Similarly, this one, the I12, we will use regularly. P implies Q, tautologically imply negation P or Q. Okay. So again, this is I took from Veerarajan book. So most of the think are already saw idempotent law. I think P or P equal to P. So you can see here P or P equal to P in the bottom. P or P. Okay, here the first one idempotent law. Yes. P or P equal to P. This is primal form. This is dual form. So you should replace R by what? And similarly, P or F equal to P. For this, I don't give a name. You can see here P or F equal to P. P or F equal to P. I told it just I9. So in Veerarajan book, they gave it is a identity law. P or F equal to P. Similarly, dual na you should write R by what and F by what? T. P and T equal to P. Similarly, dominant law. So I also gave in the previous slide just P or T equal to T. Okay, that is we call it is a dominant law. P or T equal to T. P and F equal to F. And then complement law. I already gave without this name. P or negation P is what? T. P and negation P is what? False. R by and T by what? False. Once you know the primal form, you can write easily dual form. Commutative, P or Q equal to Q or P. Similarly, P and Q is equal to Q and P. Associative law, we saw already there as dual form. Distributive law also we saw there dual form. Absorption law, okay, absorption law we saw here, dual law. De Morgan's law also we saw there. Once you know this, you can write the dual form. Okay. I think still you have three more table. Okay, then I'll stop today's class. So here equivalence of equivalence involving conditionals. So here the conditional means one way, or okay, the RA is one way. Biconditional means the RA is in here two ways you have. So P implies Q. Already I told that P implies Q is negation P or Q. Most of the time I'll use this one. So P implies Q is also equivalent to, okay, negation Q implies negation P. The problem is now you know all the formulas, but the thing is where I should use which formula. So that is the next thing. First of all, you should know the formulas. Okay, next, which formula you can use in which place. So that is very crucial. That is comes only if you practice the problems. Next, P or Q. P or Q வந்துட்டு negation P implies Q. Okay, negation P implies Q. I think can you write from? I think 1 and 3 are slightly equivalent because 3 I will write, check it, negation P implies Q. Okay, wow. Suppose I will take right like this. Okay, this is equivalent to, I don't know, I'll check it. So P implies Q na negation P or Q. So appa idoda negation na varum. Negation of negation P is what? P or Q. So that's all. I'll get what? P or Q. So once you remember this, you can write what? 3 easily. Okay. Next, P and Q. Again, the fourth one is slightly different. It's difficult to remember. Okay, from my point of view, I'm telling. P and Q is equivalent to negation of P implies negation Q. Okay. So it's possible you can remember, or otherwise try to find a way to remember like this. So I told 3 is coming from first. Similarly, you need to identify how you can easily remember 4. So is it possible to first you should write P implies negation Q is what? P implies negation Q. You need to split like this. This is equivalent to negation P or Q. Q is what? Negation Q. So I need negation of this portion. Okay, wow. Negation of this portion. So this is equal to negation எடுத்துட்டேன் P வந்துரும் De Morgan's law. Okay. So now I got what? 4. So this is the way you need to remember, because it is very difficult to remember all the identities. You know that. So you should find a way to remember these identity. Okay. Next, fifth one, negation of P implies Q is equivalent to similar way. Okay, first you should write P implies Q and then put what? Negation. So basic is the first one. Okay, first one and second one. From the first two, I think you'll get up to 3, 4, 5. Okay, next I'll go to the sixth one. Sixth one, okay, P implies Q and P implies R is equivalent to P implies Q and R. Okay, wow. So how to remember this again? Okay, so P implies Q, how you can write? Negation P or Q, you can write. Okay, and P implies R, you can write what? Negation P or R. Okay, so now negation P, I'll use distributive law, R, Q and R. Q and R. So now P implies Q. Okay, same as what? Negation P or Q. So negation P or Q is equivalent to what? P implies Q. So instead of negation P, here I have P. So instead of negation P, I should write what? P. If it, and then I'll put what? Implies the second expression, Q and R. That's all, over. I got sixth one. So it is slightly, for me it is difficult to remember. So I'll take the left hand side. P implies Q is equivalent to what? Negation P or Q, and Q implies R is what? Negation P or R. Just I will use from here to here distributive law. Once I use distributive law, and then again I use the first one. From the left, I usually will go to right. Sometimes you will come from right to left, because this is equivalent. Okay, so you should know wherever you have negation P or Q, you are ready to write, that is P implies Q. So that's why we got this. Similarly, you can try for 7, 8, 9. The same idea, I think so. If you try, you will get it. Okay, next equivalence involving biconditional. I already told that P biconditional Q is equivalent to what? P implies Q and Q implies P. When we discussed this biconditional, the truth table. Okay. So the other one is P biconditional Q is equivalent to what? Negation P negation P, biconditional negation Q. So you need to okay, how you can get it, this one. Okay, that is a slightly P biconditional Q. This is P implies Q, and okay, here also you have biconditional. So using truth table you can get it, but using identity you can try, but I don't know. Okay, a P biconditional Q try is equivalent to here also biconditional. Okay, P, that is the basic one is this. P implies Q, and Q implies P. This is the basic one. Okay, so similarly I'll write negation P. I'll write. So if I don't know anything, I'll take both left hand side and right hand side. Okay, so this is equivalent to apply the same thing. So apply the same thing means you'll get what? Negation P implies what? Negation P implies negation Q, and negation Q implies negation P. Suppose if you know any idea, you can tell.
The P conditional Q is negation P or Q.
This one, okay,
Yes, sir.
negation P or Q, okay, and negation Q or P.
Or P.
Okay, next, here also you are going to write
Sir,
okay,
right hand side we can apply once, sir.
this here.
Yes, sir.
So
In
this is equivalent to P or negation Q or. Okay, okay, yes, very good. So I think I am getting, and Q or negation P. So these two are the same. You can check it. So this is for negation P or Q, that is here. The first one is the second one here. The second one is the first one. So P or negation Q. Okay, now here you have and very good. Thank you. So in this way, you need to write and check it how these two are equivalent. Okay, similarly, P by I leave it the remaining two, 3 and 4 to you. You can check it. So either you should remember, or you need to write like this and then get the proof if possible, or at least truth table you need to verify. Suppose if you don't know how to prove this is equal to this, or you can check it in the truth table, and then okay, these two are the same. Okay, P biconditional Q. But in the examination, you can replace directly. Okay, well, there is no need to prove. P biconditional Q is equivalent to P and Q or negation P and negation Q. And the fourth one, negation of P biconditional Q is equivalent to P biconditional negation Q. Okay. Please check 3 and 4. And then last one, implications. So here you can see the first one and second one. So P and Q tautologically imply P. Similarly, P and Q tautologically imply Q. Sir, both of them are left hand side is same, the right hand side is different. Yes. Wherever you need, suppose if I need P, I will use this one. Suppose if I need Q, I will use this one. So depending upon the places what I need, I can use. Similarly, for third one, P tautologically implies PRQ. Similarly, you can write Q tautologically imply PRQ also you can write. Yeah, that is not, I think that is not here. Okay. So P tautologically imply PRQ. Similarly, you can write what? Q tautologically imply PRQ. So next, negation P tautologically imply what? P implies Q. So suppose if I want to prove this is this tautology imply this means fourth one. Okay, what you need to do? A truth table negation P implies Q is what? Tautology. If I prove this is tautology, then negation P tautologically implies P implies Q. Similarly, Q implies P implies Q. Okay, I think these one I will not use regularly. Fifth one, negation of P biconditional Q implies, that is tautologically imply P. This one also I don't know. I'll use regularly. Fifth, sixth, seventh I don't use, but eighth I will use. P and P implies Q tautologically imply what? Q. Similarly, negation Q and P implies Q is tautologically implies negation Q. Negation P and P or Q is tautologically imply Q. 11th and 12th. Okay, 11th and 12th. Here you can see here using truth table you can verify, or if possible using identities try to get it. The problem is here from here to here only you can go. From here to here you cannot come because this is a one way. So P implies Q and Q implies R is equivalent and not equivalent. Tautologically imply P implies R. And here P or Q and here R here implies and Q implies R. I think the 12th one I think I never used that last one. Okay. I think I'll stop here before leaving. Next class, actually, I'm going to start from this problem. Just I will explain this problem and then you can leave. Next class also I will explain this problem. So because we learned so many identities, if I solve one problem, then you know how we will use these problems. Okay. P implies Q and Q implies R equivalent to P or R implies Q. Okay. First, P implies Q, left hand side I have taken. P implies Q and what? Q implies R. So we know that P implies Q is equivalent to what? Negation P or Q. And R implies Q is what? Negation R and Q. Now, here R, here R. Okay, RQ, RQ. So, distribute. So, strike out. So, that's we need to use distribute. Okay, first I need to eliminate what? This conditional statement. So, I remove the conditional statement. Once I remove the conditional statements and then I need to use either distributive or associative or De Morgan's law, depending upon the places. So here I have RQ. That's why negation P and negation R, RQ. And then from here to here, I used De Morgan's law. So negation P and negation R. Instead of this, I'll take negation outside. Negation of what? P, here and now, here R. Sorry. And finally, again, this is negation P or negation P or Q is what? P implies Q. So we know that P implies Q is what? P implies Q is negation P or Q. Similarly, negation P or Q, you can write what? P implies Q. So that is the last one. So this is a very simple problem. Okay. So here onwards, we will discuss more problem in the next class. I will tell next class through in the WhatsApp group. Okay. Thank you, everyone. And if you have any doubts, you can ask to me. Otherwise, you can leave. Okay.